Thermal expansion. Let's look a bit more at the thermal expansion upon which the thermometers we just discussed depend. Now, most materials expand when their temperature increases. For example, liquids expand in a thermometer. A tight metal jar lid can be loosened by running it under hot water. These are just some examples. We're going to consider two types of thermal expansion in this section, linear and volume. Let's first consider linear expansion. Suppose a rod composed of some substance has a length L0 at an initial temperature T0, as depicted in the picture below. If the temperature is changed by an amount delta T, let's say increased, then the length changes as well by a positive amount delta L. If the change in temperature isn't too large, the change in length should be directly proportional to the change in temperature. So we get the second one of our diagrams here. At the higher temperature, T0 plus delta T, the length is increased to L0 plus delta L. If we relate these two, we'll find that the change in length is given by a constant times the original length times the change in temperature. The constant here is alpha, and it is the coefficient of linear expansion. The following table shows linear expansion coefficients for a number of substances. What's important to note here is that these coefficients are actually quite small, 10 to the negative 6 per degree Celsius. That means that for something like aluminum, it would take nearly 500 degrees Celsius to change the length of a bar by 1%.